This portion of Sports Car Revolution is brought to you by APR and Stasis Engineering, racing to make your Audi better. My predisposition to like Audis doesn't start with the fact that it's an extremely well-built German car. It starts with the fact that it's all-wheel drive. Once you've gotten into all-wheel drive, it's really hard to get back out of it. Now, what you're looking at is probably the most underrated of all of the German cars, and frankly, we don't know why. So what we thought we'd do is embark on a build-up to show you how good one of these things can really be. Well, we've talked Fred Baker into providing the car. Now, Fred's an Audi dealer who's got some vision. He's going to end up with probably the best, the fastest, and the most impressive Audi A4 to the deal. He's not going to pay a dime to do it. Paul Lambert from Stasis Engineering is the lead engineer on the project.
We chose an Audi in the beginning because we were engineers, and no one had done it before. And there was this deep desire to go and to prove that we had an engineering capability that could outdo what other people had done and could prove that the four-wheel drive concept would work where people said it wouldn't work. And we went out and we did that, and we proved it on the track, we proved it every day on the street, and today we're proving it in thousands and thousands of people's personal cars. We are racing guys. Our roots are deep into racing. It's where we started. We were engineers, and we started in a world where people were racing these vehicles and they weren't getting everything out of them. And to that end, we, over time, formed a business just to develop products that would enable us to do that.
Now, this build-up will be based exactly on the race car. In other words, what they've learned from the production A4 goes on to our Audi Ultra Sport. Now, on the power side, we've got Stephen Hooks from APR working on the car.
Well, APR is an engineering firm, and we're dedicated to bringing only the best. We employ roughly 10 engineers to do that. And we want the kind of drivability that you find as a car comes from the factory. We want to give you more power in doing so. We want to give you a car that's powerful, yet reliable. And we work day and night to do that. Audi and Volkswagen VAG is given an excellent base. This engine is pretty much bulletproof if you're doing the right things. So that's an excellent base we start from. Secondly, what we do is we go the extra step in anything we do, whether it's software or it's hardware. Our engineering staff makes sure that if it hits the road and we release it, that it has the APR stamp of approval.
So when it all comes together, we're going to have not only a car that's fun to drive, but it's going to be absolutely potent on the street. And what we'll do is we'll benchmark this thing. We'll get Jeff Lorman and Chip Herr to jump in too.
Well, we're here with the Audi in its completely stock form. We're going to set some baseline 0 to 60 times. I got the traction control on. This is the car exactly as it comes from the factory. 60 comes right at the top a second, right at the rev limiter.
Now, I don't need to be sold on the virtues of the Audi A4. That's exactly what this Ultra Sport is. And apparently, with some snazzy wheels that do make the car look a little nicer than the stock A4.
Which is all-around great car. Anybody who's ever had an Audi or owned an Audi knows that they're all-around, all-year, good car.
We're going to try and improve it, which may be a hard task, but we have Stasis Engineering on board for the suspension, and APR is going to help with the engine build-up. With guys like that really know what they're doing, it'll go from a great car, perhaps, to a phenomenal car. Where we're going to do a bunch of modifications to it, and we're going to test the car after every modification to see what does it do. And we're actually going to measure it. We've got the car all wired. We're going to measure it to see exactly what it does, not just seat of the pants, but actual numbers on the track.
So the object here is to get this thing about 350 horsepower, and when we do that, we're going to have the inherent problems on how to get the power down, how to get the thing to turn in, and what it's like when it does come off the corner. Now, this probably isn't the kind of a thing that you're going to want to watch and then buy a bunch of pieces and bolt them on your A4. Indeed, if you're going to embark on something like this, you need to work with somebody who knows what they're doing. To think that at the advent of all-wheel drive, all of the pundits that were involved in the sport were saying it was too heavy, it was never going to work. Audi went on to change a lot of people's minds. Now, with our Project Audi, we found ourselves here at the track. We've already done the testing, and now APR and Stasis have arrived. Now, APR's first system, which is a very unique system, can really be downloaded from anywhere in the world, so long as you've got an internet connection.
That's right. Our direct port system, we call it direct port because we load the software directly through the OBD2 port. Simply what you have to do is go up to an APR dealer. We have dealers all over the country, all over the world. The dealer will simply program through your OBD2 port. They'll load the software. It comes from our servers, which are located at APR. You can have stock mode, chip mode, a valet mode, a 100-octane mode, and these are all accessible through your cruise control stock. It's a very easy system. It's very integrated, and it's very simple for anyone to work.
Of course, tuning is just messing around with cars unless you've got some way to measure it. Now, we're going to measure a whole lot of APR software and hardware, plus a lot of Stasis engineering suspension work. How we're going to do that is go to the racetrack. And at the racetrack, we always find Colin Harmer from Stack.
What we're going to do is use a Stack onboard data logger, which is similar to the one we use in Speed World Challenge and other race events, to monitor up to 8 channels of information, sample those at up to 50 times per second. We should get some very accurate information.
Well, now we're going to need a driver. And when we need a driver, we go to Jeff Lorman.
So back now in the slightly less stock Audi, they plugged their laptop into the OBD2 port and gave us what they're claiming is 45 horsepower. Well, let's start with the 0 to 60 time and see what happens. That's definitely much stronger. 60, there we go, right on the top of second. Definitely a lot stronger than what it was. Whoa, a lot more torque down low. Comes off the corner a lot harder. Took about 10 minutes to do that, to change the software with the laptop, and it is much, much more powerful down low. Comes off the corner much, much harder. That's very nice. We have a lot of other modifications to do now, and hopefully we can get that increase of power up high so it pulls like crazy right through the rev range.
This is a quicker car. And as we come down this short chute into a hairpin, we'll just see how much power we've got coming off the corner. Great balance there. And then normally where we're flat out, there's actually a little bit of lift because there's more speed. And in this particular case, dealing with this car is difficult because it's become more of a handful, quicker off the corners, but still doing what Audis do so well. Stay planted, be predictable, and have gobs of traction, especially from the low-speed stuff. Now, up around just over 6,000 RPM in the upshift, we start to see that not only are we creating horsepower, we're creating it over a slightly broader band. In other words, it's pulling where the old Audi A4 would kind of give up the ghost. At the end of the day, 45 extra horsepower is very useful in the Audi, but the interface with the driver, the fact that you can actually turn it off, make it absolutely stock, there's a valet mode, there's an anti-theft mode, all of this is a highly engineered consumer product, not just a go-fact part. But does it work? Oh yeah, baby. It works. We're getting ready to add injectors, but before we did that, we also added something that car guys all know about. We added a bit of love. All of the guys from Stasis are here. All of the guys from APR are here. Mark Hotchkiss is here from H-Sport. And then, of course, we've got our own Sports Car Revolution crew. Every single nut and bolt on that car has been tightened, checked, retorqued. That car is probably as good as any car has ever left from the factory. This time, it's all about injectors and how to get the software to make them work.
That's correct, because obviously changing the injectors, we're going with a larger injector. So obviously if we stuck the old software in or stock software, we'd have problems with flow. So what we do is we go in and we calibrate the new software with the injectors so everything operates like it should, and therefore we can increase power higher in the RPM range. So therefore it pulls where the old software would die off, taper off at around 5 to 5,500. We now can go more toward redline with a higher amount of power. Obviously, when we're doing the software, whether it be for injectors or for anything, there's a lot of testing that goes in. We break the code down and we get it down to its raw base form, then we go back and figure out what everything does. From that point, we get a car and the testing starts. We test on the road, we do dyno testing, and we make sure the product's 100% before it hits the road. And then after that, we do ongoing updates along the way to improve the product at every step of the way.
The data was very interesting. From the addition of the injectors and that software change, we saw a reduction of almost 0.8 seconds in our 0 to 60 time. But that's just one part of it. When we had a look at the track data from Jeff's laps, it was really impressive. Not only an increased top-end speed at the end of every straight stretch, but his actual pickup out of every corner was dramatically changed as well, which proves that there's a real increase in drivability of this car. You know, normally when we're at the racetrack, we're fighting for pole position. We're trying to find tenths, hundredths at a time. And to see a change like this that makes such a dramatic change in the car is absolutely stunning. I mean, we're picking up 5, 7 miles an hour at the end of every straight stretch. Those are changes that are just unachievable without some significant changes to a race car. So from a street car point of view, these are really landmark changes that everybody will feel.
So the first time out, basically, it was just a computer upgrade. It made the bottom end a lot stronger. The top end remained a little bit flat, and they discovered that this was basically a fuel problem. They developed a proprietary injector and their own special tools to install it. It made the top end a lot stronger now as well. A huge increase in the performance of the car with very little money. You're talking about $1,000, and it transformed the car into something that's extremely enjoyable. What comes next is an exhaust system, and they tell me that that'll improve it again. So far, they've been right on the money. I want to see what happens next.
Already, Freddie Baker has got way more Audi Ultrasport than he bargained for, and that's just with a couple of steps from APR. By the time we're finished, he's going to have the hottest A4 software. We've been through injectors. What we're going to do now is add an exhaust. Now, an exhaust is mandatory for the street guys to let everybody know they're serious. Normally, it looks like a juice can with a chrome tip on it. This is a highly engineered exhaust. APR says that we're going to make 12 horsepower with it. Let's just see how that works out.
All APR exhaust systems are designed around a couple things. We're looking for the function of power, and we're looking for reliability. All the systems are T304 stainless steel. We use mandrel bending on every one of them. We also use CNC hangers, so the exhaust does not wiggle or move once it's installed in the car. It comes with a lifetime warranty, so if it ever has a defect or rust or anything like that, we will replace it, or if there's a problem. And the horsepower gains are obviously there. One thing to remember, all turbo cars respond much better to exhaust systems than normally aspirated cars. So 12, 15 horsepower or more on some cars is not unheard of.
For this system, like all the other systems, we're going to quantify it by use of Stack and Colin Harmer. Now, when we see Colin Harmer at the racetrack, he's normally running between 18, 20 teams. He's not a guy who can stand around and talk much. We have his undivided attention for a week. And finally, we're going to get inside his head and find out what all the doodads and all that data on his screen actually do.
Well, you know, when we're working with pro racing, it's not uncommon to be logging 10, 20, 30 channels of information at a time. But really what it boils down to is 4 fundamental things will give us as much information as we can possibly use here. That's engine speed, vehicle speed, lateral G, and longitudinal G. Those 4 components, when we look at them all, will give us a really clear indication of what these changes that we're making to the car are and how they behave. So by laying over different parts of that information on the track, we can see how the car accelerates, decelerates, see how it turns in, see what the exit speed's like. And like all things with racing and data, the data's not everything. What we have to do is go back and talk to the driver, have a look at the information we've gathered, and make sure that what we're seeing is what's actually going on. One of the biggest changes that you can make in the way the car behaves is actually with the driver, and data is absolutely the best tool for analyzing that. And it's amazing now with the cost and improvements of both the computer you have at home or in your laptop and what you can put in the car, you can find time a lot quicker with data systems sometimes than with adding extra componentry to the vehicle.
So again, back out to the track in the A4. The same mods as before, the increased fuel injector and the computer program change. Strong at the bottom end, stronger at the top end. Now there's an APR exhaust on, which they tell me is going to improve it again. Let's see. Well, definitely a throatier sound. It's about another $1,000 or about $1,900 or so into this project. And everything we've done has actually worked. It's made the car extremely enjoyable. These modifications alone make the car worth the money. Beautiful stainless exhaust, uses the original factory hardware, all CNC machined the mounting bracket so that it fits exactly. It is adjustable so that it fits into the stock location. No rubbing, no banging, perfect fit. Time to head back in with the car now so they can continue the upgrades. Let's see what they've got next.
You know, I've been so critical over the years of the juice can muffler syndrome. I just don't see any point of having something huge and hanging down just to let everybody know that we've got a performance exhaust. The tuner boys seem to want you to be able to see that. This understated system, as it presents itself at the back of the car, looks rather adult. And the sound, well, you can hear it for yourself, doesn't change all that much at all in the cockpit. It does sound a little throatier and a little boomier outside the car. That's a function of lack of restriction. You can definitely tell this is a turbo car when it drives by. With software, with injectors, and now with exhaust, we've got ourselves an A4 that makes all kinds of power. But the professional drivers agree, even some of the journalists that we've had drive this car agree, that now we're starting to see the weak link. Now we're starting to need brakes more. We're going to need to flatten out this car if we're going to improve its potential. Our Agent Coronado House control car is still a great car, the same one we started with, but it's beginning to suffer in comparison to the APR car. Faster in every way, it's just really woken up that car. And we're going to continue here, and APR is going to bolt in their big turbo package. Now, it's going to take them some time to do that. The weather here is cold, and frankly, Audi sells most of their cars in the Northwest and the Northeast. And if it snows here today, after the APR guys are done, well, I'm saying bring it on, because that's when you can really begin to sense what all-wheel drive can do. We had an opportunity last year with Agent Coronado House to bring a lot of their customers and cars out on a snow day, and you wouldn't have believed how much everybody respected all-wheel drive after that. In the meantime, we'll keep logging control apps this little A4. Our Audi A4 Ultra Sport is at the beginning and the end of the day a turbo car. Translated into car guy language, it means don't do this at home. People who mess with turbo cars usually end up in catastrophic bottom-end explosions.
The stock turbocharger is small, and it's a great little unit, and it's designed to do what it's supposed to do. But when you go with the larger kit, you go with the 340 horsepower kit, there's a couple things that go into play there. You obviously want drivability, and you want power.
With the large turbo upgrades for these kits that tend to generate excessive heat, turn very high RPMs, some very simple precautions can be taken using a synthetic oil, using a good coolant, also allowing the turbocharger to heat up slowly before you wail on it and beat on it on the track. Then also, after you've abused the turbo a while, allow it to cool down slowly before you completely turn the motor off.
You want a clutch that holds the power, holds the torque, but also has drivability like the clutch you took out of the car, a difficult item. So you've got to select, the proper material, you've got to select the proper spring rates in the actual disc itself, the proper rates in the pressure plate itself. So again, there's a whole level of things that go through there, decision-making things, changes that are made before you get the final unit you're happy with.
So now APR's installed their Stage 3 turbo kit. It's a huge compressor, massive intercooler, reprogramming the computer to better utilize the fuel injectors, and it's on its proprietary APR Inconel exhaust manifold. The thing is absolutely hyper now. It's got wheel spin when you take off. You really see the weakness in the tires and brakes now. The brake pedal is on the floor. The car is truly a hypercar now. They're claiming 345 horsepower, and it feels like a lot. It's got a little bit more turbo lag because it's a bigger compressor, but it's actually pretty drivable, and when that boost comes up, it is really mind-numbing. So now the car has all this power, its weaknesses start to show up. The tires and the brakes are some of those.
So at roughly 340 horsepower, we're beginning to overuse some of the other systems in this rather overwhelmed A4. First of all, we use the brake pedal a lot harder. Second of all, we're steering the gearbox around a little bit more. And third, jumping on the throttle just before the apex simply doesn't work anymore. You have to be a little bit more judicious with how and precisely where you open the throttle. In this big, sweeping right-hander, we're having to lift just a little bit before we exit and then make an upshift, I'd say 120 meters earlier than we would have before. Absolutely brilliant. But you know what? We're using too much brake and way too much body roll. So we'll have to continue with some modifications. Paul Lambert sat on pole at Mid-Ohio and then later won the Laguna Seca round of the Speed World Challenge Touring Car Championship. He blew up a lot of myths. In touring car, an all-wheel drive car was always going to be too heavy to compete with the BMWs and the Acuras. Well, when he sat on that pole and when he won the race at Laguna Seca, he changed a lot of people's minds. And on the podium, he attributed most of that to, modestly, his Stasis engineering suspension package.
When you cross that finish line and you walk up onto the podium at the end of the deal and you've got the Audi brass and you've got the Speed Channel people there, it's a culmination of a dream. It's a culmination of everything that you love about both the vehicles, the engineering, and at the end of the day, the people that make it all happen. It's a great feeling.
We're going to take that racing suspension in its street form and apply it to our Audi A4 Ultrasport. By the time we get done with this particular step, we're going to have a real driver's car that they tell me will be good for the track and especially for the street.
The spring at the end of the day is what holds the vehicle up. It's not necessarily every characteristic of the vehicle. At the end of the day, the damper controls a lot more of what it feels like. The spring controls a lot more of the ride height, the ultimate stability of the vehicle. We're going to try to pick the lightest spring rate we can get away with, yet run it at the ride heights that we want at the level of performance we have. At the end of the day, that spring rate's pretty high. We'll be twice the spring rate in this vehicle, but yet when the damper's good, it'll ride just like your daily driver. Many people say it rides better than what they came with when they first bought the car. The damper controls the initial response of the vehicle. It's the transitional response control of the vehicle. When you first steer the vehicle, you step on the brake. That initial response, that's all the shock. It's all the damper's job. And again, the potholes, the bots, dots, the ride quality comes out of the damper. When you turn in the vehicle, the damper does its job. Once you're in a nice stable state, you're in a good, long, sweeping mountain road turn, now you're relying on the springs a little bit. But that damper really does everything. There is no such thing as one perfect suspension. Every suspension is different. We've been to World Challenge Racings, and you've been there, where I have two drivers. Michael Glotti's in one car, and Paps is in another car, and we've got 600 pounds of spring rate on one side and 1,000 pounds on the other, and they're within 0.2 of a second. There's no one perfect suspension, and that's what the goal is of being able to adjust the suspension, is to fine-tune it for your capabilities. Don't try to over-engineer the solution. We've spent a lot of engineering in there. We've given you a range of what to do with it. We've given you some recommended settings. Go with a good manufacturer that's already done that homework for you, and then just fine-tune it to what you actually like, what makes you comfortable driving at the speeds you want to drive.
With that huge increase in spring rate, you think the ride would be incredibly harsh. But Stasis have worked with Öhlins to develop a shock that you can barely tell that there's any suspension modifications at all until you really lean on the car. So actually it has quite a nice ride until you lean on it, and then it is flat as a board.
Now, second time in the car with this extra power, we find ourselves in a little less of a pickle just because the car is flatter. It also has the characteristic of maybe putting the power down just a little bit better, owing to the fact that the car is not tilted over as much. Approaching the car, you notice that the ride height is lower right away. It doesn't look like you're going to get much steering lock to lock, but these big front tires turn very nicely in the wheel wells. All in all, this car is becoming more civilized, and it is still astonishingly fast. However, we need brakes. They're pretty much cooked. So the next stage, brakes, that's going to be a good addition. Revolution. You know, the benefits of all-wheel drive have been long and storied. Not only do you get better traction, of course, in all sorts of weather it works better, and gravel it works better. You get better control, even on dry pavement. The fact that you've got 4 tires searching for grip makes for a better automotive solution that when most people try, they have a hard time going back to two-wheel drive, whether it's on the front or the rear axle. But would you believe that all-wheel drive actually poses an advantage for braking as well?
Because of the all-wheel drive system really makes a mechanical connection between all the corners of the car, the brake resources are really somewhat shared. It may in fact be the ideal arrangement because balance of the brake system isn't as critical. Because of the mechanical connection, some of the work of the rear brakes can be shared by the front and vice versa.
When we come back, we'll continue work with APR and Stasis Engineering on our Project Audi. First time I talked about Steve Ruiz about putting big brakes on a car, he talked about modulation, he talked about performance and balance, he talked about many other things, but one thing he never said was awesome stopping power.
You know, we can achieve the same torque result, same brake torque in a wheel application through changes in piston size
or effective radius, or friction. We could, for example, put on just a high friction brake system, but then we wouldn't have the other parts of the system to go with it. If we're going to do more work and we're going to do it in a shorter length of time, we need heat capacity. So we have to be able to absorb the heat during the stop better. We have to be able to release it faster so we're able to do more work at the next corner.
This immediately endeared me to Steve Ruiz and the whole StopTech Brake Corporation. Now, we're not going to use StopTech pieces on this car, but it's time to get the car to slow down more predictably. We're not actually looking for a shorter stopping distance. That's the kind of fool's play that the advertisers and magazines tell you about. What we're looking for is control.
Braking is really, either the most or the second most important thing you're going to do. You're going to get up to speed, and then hopefully you're going to get back down from speed. And how, where, and how many times you do that is the goal of the brake system. Actually, braking componentry is expensive only if it's the wrong componentry. Braking componentry, when done right, can last the lifetime of the vehicle. It'll certainly last. The right brakes and the right application will last much longer than something that wasn't designed for that vehicle. We put 340 horsepower in this vehicle. We're going to go through an awful lot of 10.5-inch rotors, probably 2 or 3 every day we come out here. Every caliper that we put on the vehicle, and we use the best Alcon monoblock calipers that are available for a street car. Those calipers are designed with bore sizes, piston sizes that exactly match what the ABS pump is expecting to see. In that instance, it's going to run at the same cycle rates. It's going to have the same effect that it would in a stock application. When we get down to braking a vehicle, there's really 3 different things we look to do. A, we look to stop once. Want to stop before that stoplight comes up. That's all a function of tire. Put the best tire we can on the vehicle, that's going to slow it down. B, we decide we're going to do this 10 times in a row. We're on our favorite mountain road and we're diving in and out of turns. Now we've got a rotor issue. It's what gets rid of the heat every time we want to do it again. We've got to upgrade the rotor. And the third level is we want to be able to control the fine element of how much braking into a turn, how much braking out of a turn as we roll into the throttle. Now we need a really good caliper. Each time we upgrade our level of expectation, we have to upgrade the componentry. Still has to balance, still has to match the factory system, still has to use the ABS properly, but each level will enhance that experience. And that's the 3 levels we go through when we come out here. Pedal feel to a race car driver and to a real sports car driver out on a country road is all about the confidence in your ability to go in and out of that turn. And the ability of that caliper to tell you what's happening at the rotor, and it can do it. It can tell you exactly how much that brake is heating up, how much it's gripping, and how much the tires are gripping. That ability is in the technology of that caliper.
So now our Project Audi has crazy power and a great suspension, but the brakes were right on the floor. There was incredible fade. You had to start braking nearly halfway down the straight in order to get slowed down for the corner. We ended up putting 14-inch rotors on the front and 13 on the back, 4 piston calipers on the front, and the stock caliper on the back with some really aggressive brake pads. And to say that the brakes are aggressive and slow the car down is a huge understatement.
Now the difference in this car is just unbelievable. The car stops right when you want it, and it's just superb braking. Anytime you go into one of these turns, you just stab the brake, and it is so responsive, and there's no slack at all on the pedal. And it makes, for any kind of road racer like myself, you want to have confidence. That's one of the most important things about a sports car is having confidence in your car and knowing it's going to either have power when you want it and it's going to stop when you need it to.
So we'll get down to the end of this straightaway here, build up as much momentum as possible. The other guys have warmed them up for me, so let's see how deep we can go. Jeez. The sunroof actually closes now as you're under braking. Now that is worthwhile. Probably the biggest misnomer in all of tuning is sway bars. Properly termed anti-sway bars, their function is simply to stop the body from rolling when the car is going through a turn. Now, you can do that or you can overdo that. This has to be a properly engineered part of our solution here for Stasis Engineering. For that, they went to H-Port, and Mark Hotchkiss has been here for the entire build. Now, done improperly, sway bars can render a car absolutely indrivable. So heads up, we're going to add a sway bar, and we're going to evaluate exactly what that does for our A4 project car.
All of the pieces that we design and manufacture complement other pieces. Let's say springs, sway bars, strut braces. They all complement each other. None of them can do the job by themselves. With this particular project today, we're dealing with the Audi A4, and we get many compliments on our sway bar kit that goes with this car. And people say, they write in or they call in, why didn't it come from the factory this way? There are many reasons why, but from our point of view, it's great that it came that way from the factory, because we can take it and we can baseline test it and make some drawings and some assumptions on what we think it should be, test the pieces, and then put them on the market, and people seem to like it. APR and Stasis have associated themselves, and Stasis has a long racing history. We'd like to do that too in the future.
Well, there you have it. Science 101 on a sway bar. Now, not only does it look good, it's functional. It actually works integrated with the rest of the parts that Stasis Engineering has bolted together on this car. Every step of the way, this car has gotten better. Now let's see what the old guy and the young guy have to say.
Driving the Audi with the addition of the rear sway bar makes it rotate a lot less. It actually is nice and controllable with the throttle. You can modulate the throttle and get the car to turn in a little sharper if you need it to. A lot of suspension tuners believe that the handling of the car comes from the springs and shocks, and the sway bars are used for tuning only. In this case, tuning the car with the addition of the rear sway bar made a huge difference. The car, like I said, hardly has any understeer. Once we put some big tires on this with these huge brakes, the thing will be so ferocious, you won't be able to wipe the smile off your face. It's hard to believe that this car could be any better, but Stasis assured me that with the addition of their differentials, adding more power to the rear wheels, the car will be even better.
All right, now that we're out test driving this Audi, after we put the suspension on, now we have put on front and rear sway bars. Now, after you lower the car, it lowers the center of gravity, gets rid of the ride height, and makes the car not only look good, but it's got better stability in the corners. Now, with the sway bars, it's all a part of a kit, which without the sway bars, you don't have the complete kit. You got to run a different, higher spring rate in the rear to compensate to make the car real nimble. This car right now is real stable, and it turns in much, much better. Before it had a lot of understeer, and now it seems very, very neutral, where we're actually having this pressure on the rear where we can lay down power with front tires instead of losing grip and spinning the front tires. Now these sway bars also have adjustments, so if you do everyday driving on the street, you can have a neutral setup for everyday driving, or you can have a stiff setup for autocrossing or any kind of road racing. For
Audi built its reputation on one thing, and that's Quattro. That long-suffering device of four-wheel drive has gone 20 years and made them distinguished in virtually every form of motorsport. Now, the Quattro system works exceptionally well for the street, but for the track, Paul Lambert and Stasis Engineering wanted to improve it even more so that the car came off the corner better. Now, this is not a sexy ingredient. It isn't shiny, it isn't bling, and it doesn't have Stasis Engineering engraved onto a stainless steel nameplate. However, what it does do is it improves the performance of the car, especially on the track, dramatically. Our drivers had a crack at it, but first let's check in with Paul Lambert and talk about that system specifically.
We've changed the center differential and we've changed the rear differential in the car. And we've done this because we've put a lot more power to the car, and we're looking to change the character of the car a little bit. We're adding to add a little bit more sports feel to the car. It's going to squat down, it's going to come out of a turn, and I want it to really put down power when it comes out of that turn. So the center differential comes from the manufacturer. Great system. It's a Torsen torque biasing differential. Has a 2-to-1 bias ratio. That means it can put twice as much power to whichever side has more grip. And it does that ahead of the game, before you even realize it, which is great in this system. That is really not enough now that we've upped the performance of the car. So we've upgraded that from putting twice as much power to either the front or the rear, putting 4 times as much power to the front or the rear. So when you get on that car hard and you come out and you've got those 300 foot-pounds or more, instead of overwhelming the front tires, it keeps putting it to the rear as it gets more grip, and it just gives you more grunt out of the turns. It's very apparent to the drivers. The rear differential has also been upgraded. In the standard vehicle, that's an open differential, which means it's going to put power to whichever side has less traction. You'll tend to see a wheel spin up in that application. So you drive the vehicle harder and harder, and the weight begins to transfer across the vehicle, you end up with light tires. As we put more and more power in the vehicle and more power to the rear, we end up particularly with lighting up the rear tire. We see that coming out of turns. You see it spin up in the smoky tire. We get rid of that by putting a limited slip differential. In this case, it's a speed sensing plate type differential. It has approximately an 80% lockup when it finally spins up to speed, and it keeps those two wheels from slipping and spinning. And it allows the center differential to put even more power to the rear and get even more grunt out of the turns. Very apparent to the driver, very apparent when you come out of a good tight turn.
We had the opportunity to take the car on the track. Going through a corner was amazing with how the suspension was laid out and the sway bars, how the car would actually transfer the weight and the power would get laid down so much better because the transfer of the weight was going to the rear. And the front tires are pulling you through, but yet the rear tires are helping you push through. It's just an amazing combination that just blew my mind in the wet weather.
This is one of the best project cars we've actually built. It's very fast with incredible grip and absolutely a riot to drive. Switch the diffs around so that there's a lot less understeer. You can drive it with some oversteer, and it's very easy to control. A really fun car to drift.
Well, we've come to the point in our A4 Ultra Sport project where we wanted to put on tires. Stasis feels like they could fit a little bigger tire on this car, even though the Ultra Sport is a big tire car. Well, perhaps, but the trick is to get them in there and allow the car to still turn. Well, in the tightest part of our test track here at Dunnville Autodrome, they seem to work fine, and the grip, well, that remains to be seen. We've got our compound tires, and we're right at 0 Celsius, or 32 Fahrenheit, right where the snow is turning into rain. It's prime territory for the Audi. It may or may not be for these R compound tires. A tire may theoretically fit on a car, but you never really know until you bolt it on. In this case, we're having a lot of success, but whenever we're unsure, we always go to the same guy, Andrew Cantor at Wheel and Tire Zone.
The Audi Ultra Sport already comes with a 235/40/18. We've gone to a +0, a 255/35/18, maintaining the same overall diameter, but dramatically increasing the contact patch for this vehicle. This original equipment Dunlop Sport 01, which came on the Audi, has a tread wear rating of 280. We've gone to a R compound, a motorsport tire from Dunlop. It has a tread wear rating of 60. This tire will give you much more phenomenal traction in the wet and in the dry, but at the sacrifice of much rapid wear. So what offset is, on this wheel, for example, this is a 15 by 7-inch wide wheel with a 35mm positive offset. How to get that measurement is crucial. We take a tape measure and measure from rim section to rim section. This particular wheel is 200mm. We want to get the center line of the wheel, which is the dead 0 point of the wheel. That is approximately right about there, the halfway point of the wheel. We take another tape measure and a straight edge, and we measure to the mounting surface of the wheel. This particular wheel is 35mm. So this wheel is 35mm positive. This is what we would refer to as an innie. So this wheel is going to go underneath the fender well more than what a rear-wheel drive wheel, which is referred to as an Audi.
Let's hear what our star drivers had to say about this car.
The car actually, with the stock tires, had a lot of grip for compared to, for a normal car. And with all the power and with the braking and all the upgrades we put on the car, it really had a lot of grip. Now, with these tires, it's a little damp today, but we still get an amazing amount of grip, and the car really wants to lay the power down. With the torsion differential that we put in the car, really makes a difference on how the car comes out of the corner, and there's no slip at all in the tires. With all this horsepower, braking, and cornering, and now we have sticky tires, I don't know if Jeff's going to be able to handle this thing.
Our compound tires is basically a racing compound version of a street tire. It doesn't last very long, so you don't want to use it on the street, but it gives incredible grip, sometimes a couple of seconds a lap. Here at Dunnville, it's a little bit wet today, which I think makes the R compound tire really stand out. It gives it that extra grip, extra confidence in the wet pavement, and you can push really hard. A good R compound tire is really predictable to drive, and you can hang it out a little bit and make it look like you're a hero. Our compound tires also offer extra braking, extra acceleration, and a little bit better bite on turn-in. But again, with this Audi, all this extra grip, extra power, extra brakes, just makes it harder to stay behind the wheel. Again, guys, please give me a seat that I can sit in.
This car is awesome. Now, these are probably the most challenging conditions that you can imagine without there actually being snow on the road. And our Audi is eating it up. You know, normally when you tune your car, you put some parts into it, and then there you are. You never have an opportunity to go back to make that comparison. Well, to make sure that we know what's going on, Colin Harmer from Stasis is here. He's going to be taking data acquisition all through the process, which may just save us from ourselves.
All right, so you're going to get started. Really what you want to do is have a look for 4 basic parameters to help you understand what's going on with the car. You want to understand how fast it's going, that's wheel speed. You want to understand what the engine's doing, that's engine speed. And you want to understand what's going on with grip, that's both lateral and longitudinal G. Sort of as you add those 4 channels up, you can learn a whole big bunch about what's going on from a performance envelope and what's going on from an acceleration and deceleration point of view. By using wheel speed and engine speed, in fact, if you don't log the driven wheels, you can actually look at wheel spin as a function of that, because your gear ratio shouldn't change when you overlay those two. Then you can look at things like, well, are you shifting fast enough? Engine speed will tell you the difference between when the engine goes up, or engine speed goes up, and actually when the shift engages. So if you're taking too long to shift, you're giving up time. You never finish. You're always looking for it. When you start out, you're looking for tenths, 2 tenths, half a second, maybe a full second, and then you start looking for smaller and smaller incremental changes, and they're always on the table. First thing we wanted to do, get an accurate engine speed. So we actually went to the fuel injector line for that. Very easy, comes off at a 12-volt pulse, pick that up, and we know that we've got so many RPM. Then wheel speed was the next obvious one. So for that, we actually went to the driveline. Now, fortunately, with the Audi, there's lots of driveline components turning around and around. We used a simple Hall effect sensor, which basically looks for a piece of metal, and it just takes a trigger from it. In this case, we used a rear CV joint pickup. And the lateral G was really easy because we have a very sensitive lateral G sensor that we basically Velcroed to the center console. In order to get really accurate information, particularly when you're on a circuit race, you need what we call a hard line in the sand. And we achieve that by using an infrared lap timing beacon, which is a beam of light that we shoot across the track, and we actually have a lap time receiver simply taped to the top of the car. It was interesting for me. For the most part, I've not spent much time working on street cars or street tuning. So it was kind of neat to watch the guy simply insert a computer and see an instant dramatic change in 0 to 60 time. Stick in the computer again, add some injectors. Again, a dramatic change in 0 to 60 time. You know, and then as we move forward with the Stasis guys to add brakes, suddenly the deceleration curves were dramatically improved. Add new shocks, lateral G went up. Every single step we made was qualified with hard lines. The opportunities here really are that you can actually set a baseline, and then every time you go out and do something, you can actually see what the changes affected. And you may end up making some changes that change one thing positively, but another thing negatively. You can go back and find out where those changes were and why you wanted them or maybe didn't want them. So it's kind of interesting. You make this constant flowing program of improvements, and they'd be able to go back at any time and say, is this better? Is this worse? Did it improve or not improve the situation? Yeah, STAC is a proprietary piece of information that we call a predictive lap timing system, or a performance meter. And what's really interesting about it is it gives the driver instantaneous feedback at the time on the track as to what they're doing and whether or not it's improving or not improving their lap times. Effectively, it looks like a bar graph, and if the bar graph goes to the right, you're on a fast lap. If it goes to the left, you're on a slow lap. And rather than even having to go back and look at the computer for data, you can understand the changes in your technique, braking points, turn-in points, instantly can generate or take away speed. You know, one of the challenges we faced this year running the tires that we did in Speed World Challenge was that the tires really had about a 3-lap opportunity to spank in a hot lap. And unfortunately, sometimes that doesn't happen. The predictive lap timer system actually enabled the drivers to have a look, understand where they were in their lap, and if the lap was spoiled, slow down, cool off, save the tires, you got another chance to get it done. It really helped you manage traffic and understand what was going on. It's amazing, you know, the advent of PCs and chips and all those electronic costs have really driven the cost of data down to the point where really a set of wheels and tires is about what you're going to spend on a data system. The nice thing about the data system is if you look after it, it's going to last for 10 years. One of the other powerful tools that we've developed is actually a video overlay system where you can actually shoot video in the car and then sync that with the data. So if you have a spectacular event or something that really makes a dramatic change in your performance, you can look at your screen, understand where the change is, and see what's going on in the car at real time. So you actually get a real-time video of what's happening and what that data means and what the changes it affected.
Data acquisition to prove what you're doing is worthwhile to what these guys from Stasis Engineering and APR are doing after all. Well, we're just one episode away from wrapping our Audi project, and we find ourselves at the 12 Hours of Sebring. Now, this is the first round of the 2005 Touring Car Championship. Our test driver, Chip Herr, has picked up a full-time ride with the Stasis Engineering team.
Well, I'll tell you what, the car really feels good. Stasis did a great job setting the car up really neutral. I could throw the car understeer, oversteer, could lay power down early, and for a first testing session, it really felt good.
And naturally, Paul Lambert, too, is very excited about having Chip and his team to join Rick Mackey to make it a two-car effort.
He's doing very well. He's dropped into the environment well. The guys like him. He's fun. He's a good guy. He has good car feel, so he's giving us good information right now. And as we spend the weekend with him this weekend, he'll download every single session. We'll train the driver as much as he's going to train us and train the car.
I know what you're thinking. You're thinking, what are the similarities between the race car and the project car that we built?
I haven't driven many race cars that are all-wheel drive, so I mean, this is all new to me. But the street car, for the most part, you could do whatever you wanted with it, except it was heavier. Now we got a lighter car with the same options, so really, it's like, we're really excited for this weekend.
There are a lot of similarities between the two platforms. That's what makes what we do here so important. This is when we start to learn. And this is where we really learn. Chip will do 3 sessions here almost back to back with an hour gap. He downloads a little data. We learn from it. We change things dramatically. At the same time, Tom, there's so much that's the same about these cars. I mean, we're running the exact same Öhlins dampers on both the car that's sitting back there that Chip's driving back and forth to the street and the one he's driving on the racetrack. Same dampers, same valving in this case here at Sebring. We ran a little softer to get a little more grip. We're running the exact same thing that we run on the road car. So the similarities are quite apparent when you start looking at the cars.
Now, if we watch Chip and we listen to Chip, you can tell the kid's very, very excited about landing his first professional racing team ride.
Getting out of the car and having guys writing stuff down and doing things for you, it's wow. I don't even know what to say yet. It's still so new. But they're a good group of guys, and we're really looking forward to this year for sure. To have a car that I know can run up front is really a good feeling, and if I can work with the car, because I'm hungry to win, the team's hungry, Stasis wants to win, and I'm sure Audi wouldn't mind a win. For a first session, it really went well, and we were running right with top guys, which I wasn't really doing last year, so we're really pumped up about it.
As we wrap up this project now, Jeff Lorriman, Chip Herr, and a whole host of others are about to get in our project car. And so ends a great project with what some might consider a mild-mannered sedan. But Audi has always been so much more than mild-mannered sedans. Since the 1930s, in these great auto union cars, Audi has traditionally dominated every form of racing that it enters. Think of the 1980s and Trans Am and these brilliant touring cars from Europe in which Audi was basically legislated away from, the advantage being all-wheel drive. Think of the Speed World Challenge.
Too bad I wasn't involved in this project. Probably not going to work too well. Chip can't drive. Jeff's awful. But at least they got me in here to tell them what it's all about. I like what they did with this car, besides its lowered stance and its cool look. I mean, this thing works. It's a heavy car, but it doesn't feel heavy.
This may be one of the best project cars we've ever built. It's incredibly fun to drive. You can slide it sideways.
Kind of makes you feel like a hero. Like you know what you're doing.
It always comes back. Switch the diffs around to give it a little bit more rear bias. It's apparent with this Project Audi is its limits are incredibly high. You have to push this thing to the extreme to find the limit, even in the rain. They've done an exceptional job on this car. Whoa, a little off-road in there, but that's okay. I guess it isn't totally bulletproof. But it's very capable and very easy to drive. I absolutely would love to have this car on the street.
I mean, the last car that I drove that had a 1.8 in it was a 180 Audi TT, and that was a nice balanced car. But the way that this car is set up with these shocks, this brake package, and this engine mods, I mean, just awesome.
We went from 170 to about 340. We've got wider tires. We've got 4 piston calibers with bigger rotors. Full suspension by Stasis Engineering. APR did all the software and all the tuning. Now we have a car that we've been testing throughout all these processes of seeing how this car gains horsepower and handling. And it's amazing what this car has turned into.
2 things I noticed about this Audi right away. Number 1, it's red, not black. Bummer. Number 2, the seat was super far forward. I guess Chip was in the car trying to give her hell.
I'll tell you one thing. This is my last time driving a car, and I'm really upset about it because I'd love to just keep on going and just take us right home and put it in my garage. It's not just an Audi. This is darn near our 911 killer.